Welcome to the Explainer. Today, we're diving into a pretty incredible breakthrough from Google's quantum AI team. They found a way to teach quantum computers how to not just, calculate things, but to actually discover them.
For centuries, we've been trying to really get a handle on the universe. But our best computers have always hit a wall. They just can't keep up with the mind-boggling complexity of the natural world.
But this is a real turning point. We're seeing quantum computers shift from just being a scientific curiosity to actually doing science. They're becoming this powerful new tool for real, tangible discovery.
Okay, so let's get into it. What did Google's team actually pull off? Well, they announced the very first demonstration of something they're calling verifiable quantum advantage.
Okay, so this is a huge deal, and that word right there, verifiable, is everything. See, we've heard claims about quantum advantage before, but they've been kind of hard to pin down. This is different. This isn't some one-off fluke. This is reliable, repeatable science that anyone can go and check for themselves. And to prove it, they put their quantum processor head-to-head with one of the world's fastest supercomputers. And the difference? Well, it was just staggering. A specific task that took the quantum chip just a few seconds would have taken that massive supercomputer over a year to finish. And if you want a hard number on that, Google's quantum processor, which they named Willow, ran the calculation a mind-blowing 13,000 times faster than the absolute best classical method we have today. Yeah, 13,000. So the big question is, how? How in a world did they get that kind of a speed up? Well, the secret sauce is this incredibly clever algorithm they developed, and they call it quantum echoes. The whole concept is actually pretty cool and surprisingly intuitive. It's a lot like echolocation, how a bat sends out these little pings of sound to map out a dark cave. The quantum echoes algorithm does something similar, but it sends a quantum ping into a system to reveal all this hidden information about how it works inside. Now that echo that comes back, it gives them a really specific piece of data called an OTOC. And a simple way to think about an OTOC is, imagine you drop a pebble into a still pond. The OTOC measures how fast and how far those ripples spread out. It's basically measuring how a tiny little disturbance spreads through a really complex system. And that's been a huge challenge, because that little ripple, that signal, is incredibly faint and super easy to lose in all the background noise. So here's the play-by-play of how it works. First, they run a whole series of quantum operations forward in time. Then, step 2, they gently just nudge a single qubit. This is what creates that tiny ripple, that little butterfly effect. Step 3 is where the real magic happens. They run the exact same operations, but in reverse. And finally, they analyze the interference between the forward and backward trips. And that interference pattern, that's the echo they can measure. But of course, an algorithm like this is really just an idea, right? You need some serious hardware to actually run it. And for this experiment, that hardware is Google's Willow chip. And this thing is a beast. The Willow chip is a super powerful processor made from superconducting circuits. It's rocking an array of 105 qubits. Those are the fundamental building blocks. And they're all working together to pull off these unbelievably complex calculations. Its incredible speed isn't just about getting to the final answer faster. It lets the team perform millions of measurements in less than a minute. And that's absolutely crucial for pulling that one, faint, important signal out from all the noise that's around it. And get this, in total, over the whole project, the team performed a staggering 1 trillion measurements. Just try to wrap your head around that number for a second. That massive amount of data makes this one of the most complex computational experiments in history.
Okay, so we've established it's verifiable, it's crazy fast, awesome, but what does this actually mean for you and me, for the real world? This is really where we go from quantum computing just being science to it doing science.
So for their first big practical test, the team used the quantum echoes algorithm to go after a really fundamental problem, accurately predicting the shape and structure of molecules.
And you might be thinking, molecular shape? Okay, why is that a big deal? Well, it's kind of everything. A molecule's shape determines exactly how it works. So if you want to design a better drug, or build a more efficient battery, or invent some new kind of material, it all starts with perfectly understanding that shape.
And this right here is where it all comes together. The team ran their algorithm, and it predicted the structure of two different molecules. But they didn't stop there. They went into a lab and they checked their homework using traditional methods. And guess what? The results matched perfectly. This wasn't just a theory anymore. The quantum prediction was verifiably correct in the real world.
So the crucial takeaway here is that this isn't just some cool lab trick anymore. It's really the beginning of a brand new chapter in what we can do with computation. And this success gives us a really clear roadmap for what's next. The Google team is now really optimistic that within just 5 years, we're going to start seeing the first real-world applications that are completely impossible on the computers we have today. Ultimately, what this does is set the stage for a future where we can actually design better drugs, engineer more efficient materials, and create next-generation batteries, all because we can finally understand how they work at the most fundamental quantum level. And that kind of leaves us with this one fascinating thought, right? For the very first time, we have a tool that is verifiably faster than our best supercomputers at simulating nature itself. We've just unlocked this incredibly powerful new way to understand the universe. The only question now is, what do we ask it first?